Depending on like who you're playing. It's only going to 35. It's got to be taking business. You're not just saying it's a general activity. Good morning. Why no business with busy? Yeah, yeah. Yeah. I need different on the oh, no, you really like you're just have you done it? That sounds good. Yeah. I don't understand. I know there's one kid in my class, so I was like, you know, apology. Oh. Maybe I should say, oh, I remember. You got you got to there, like 33 and found out. Thank you. Yeah, you're true. You have a one. This is fair. I think I have. It's like freaking expensive. Yes, no. Organize this. I remember it's the end of the brand.
Oh, no, it's only like a.
Oh, look, that's
Which is why. Also, like, faster.
it looks like the rating's dying. That's not that's the real thing. That's not kind of that's a legendary.
I think the bus, I feel like a bus needs this now.
I was talking when you go like out in Australia.
Not too bad.
We were not. Thank you. Okay, so any questions before we get started? Anybody have reserved your spot for midterm one? Okay, so you haven't done so, please do it as soon as possible. Another thing that I want to mention is that if you later on realize that the spot that you currently have doesn't work for you, the best thing to do is actually go back and recheck the available time. The class will actually release more seats the day before the test. Okay, so if you encounter a situation like that, you don't contact me. Okay, all you have to do is actually go and see are the actual available spots. Okay, so that's actually the most efficient way to get, if you miss your original one, that's the best way you can get another spot for your test. All right? Okay, so what we are going to do today is actually to finish chapter 12. Okay, and there's actually not much left. So let's have a quick roll through about the things we have been told. Okay, so chapter 10. Chapter 10 we start to introduce you different concentration terms, right? So the biggest things for that is the concentration conversion is one of the things that you must become a master. Okay, solving that. Okay, so that's actually the most important part for your chapter 10. Okay, and after that, we start to talk about the delta H of solution, right? And then you know what's latent energy, you know what's hydration energy. And after that, we start to talk about the factors that go to influence the solubility, the pressure, the temperature, okay, for the solid and gas. Okay. Then we come to the other big things, which is a collective property. Four things, right? Vapor pressure, freezing point, boiling point, and osmotic pressure. And to know the corresponding equation for that. And that's all for chapter 10. Okay, so make sure that you don't waste your time on some unrelevant content. Okay, so I've been talking to many of you in the past couple of weeks. Okay, and every time I come to my office, the first question I typically ask is like, what's your major? What do you want to get out of this class? Right? And I want to make it very clear that I respect everybody in the class. I don't judge my students based on their grades at all. Instead, I want to have a reasonable plan for you so that you can get what you want. Okay, so I know everybody's actually very busy. So I want you to actually use your time wisely. And this is not just for this course, but for your life. Okay, so when you grow up, you start to realize, okay, not everything is actually obtainable, right? You can actually work for it in the normal situation. Okay, and when I say work for it, it's actually putting your time and effort. The time is limited. Your energy is limited. Okay, to really get the things you want to achieve your life goal, you need to be strategically planned yourself. I will address to everybody so far. Okay, so when you come to me, I will ask you how you actually do your study. Like what's the latest way you are shooting for? Right, and how many hours you are allowed to put in. Okay, I don't need you to say something fancy to me. I don't need those information. All I need is actually, I want to help you, right? I need to know your situation. Okay, so if you say, oh, I need to walk, that's totally valid. I know many of us is actually have to walk and take the course at the same time, right? And then you need to actually really know how many hours do you have and how many hours you are willing to be. So I can tell you, okay, what is actually most likely outcome and how you actually improve. Okay. The other thing is actually to save you time, right? Students sometimes doesn't really know what you should actually really spend your time on. Okay, so you can actually spend a lot of time on something that's totally irrelevant for your goal, meaning to obtain the later that you want. Okay. The things that really matter for this course, if you look at syllabus carefully, there's actually two things. One, the most important one is actually written, right? Second, the homework and quiz. So these are the three things that will eventually give you the points that you need. Okay. And I think I said this many times. Okay, so the question you're going to encounter in your midterms coming from a big data bank, right? But the questions, they're actually all quite similar. Just change the numbers inside the big data bank. So every single chapter, there's a few things they really want you to know. You only need to know those things if you're not energy major. Is that clear? Take the chapter 10, for example. This is very clear to you now that the things that you need to become a master is concentration conversion plus the collective property. Right? If you have limited amount of time, those are two topics. You want to make sure you know how to do it. Okay, so this thing to actually repeat for every single chapter. Okay, so how do we actually figure out what is actually important content for each chapter? Who will be your solution? Right? What did I provide? You have a hangout, right? You see every single chapter, you have one page summary, right? Those are the things you need to spend your time on. If you don't have enough time, don't even bother opening your textbook. Not going to help you to the level that you like. Okay, so be very clear, be targeted. Okay, know your goal is very important. If your time is limited, I know you guys are young, you'll be like, well, I have a lot of time doing this, this, and that. Yeah, you're actually at the age that allow you to actually explore the world so you can actually really find out the things that you can really enjoy. And you should definitely do that. Okay? And with that being said, okay, you also to know that the things you can achieve based on the things you have accomplished. Okay, so many of you will say, okay, what's the point? You know, there's so many equations. I'm not going to major. This is not going to do nothing for me in the future. Right? Totally valid. But that's not how you should think about this. Okay. When you come to college, the main point is actually you need to learn a few things. At least to me, that's the thing that is actually very important. First, summarize information. Summarize information is actually critically important because these are actually things you need to do in the future too. No matter what you do in the future, we live in a world that's full with information or misinformation, right? So you want to distill out those information that's relevant to you, and you need to make sure it is actually a valid, fact-checked information, right? So how do you actually practice that? You're taking courses. It's actually practice for that. Did you see that? When you start to actually learn the subjects, you see a lot of things, right? But eventually, after your hard working, there's only a few things will actually register into your brain. Those are called distilled information, right? And it's actually a process that you put in your effort so that you can really compress the things, and those things will go with you. Okay, that process will repeat throughout your lifetime. So you better be good at it. Make sense? Okay, so information extraction is very important. Second, present things in a proper language. Okay, so in the future, you're going to have your favorite job, right? How do you show that you are smart, strong, and beautiful? You talk professionally, right? How can you actually talk professionally? You need to learn the specific terms for your own career. You are practicing that now using Think Tank. Right? Using any courses is actually doing the same practice. Okay, so those are the second important things that you can actually get used to. Okay, so yes, you can actually memorize equations, but you will do the same in the future, no matter what you are going to do, right? So practice it now, so that you know what is actually most effective way you can actually memorize the key things. Okay. And the third very important thing that you should actually learn through your college life is that seeing the unseen, seeing the untold, seeing behind words. Okay, so in the textbook, they actually have a lot of descriptions, right? But you have to try to see what is the basic principle behind all these questions. Okay, you need to actually start to learn how to see deeper. Okay, because only after you see deeper things, you have advantage to be succeed in the things you really like. Okay, so those are the three things that I want you to see. Okay, don't just think of just taking a course. Okay, all the things I say is a lifelong experience. Okay, so make sure you start to practice that. Okay, so seeing the principle is so important because once you know the principle, once you internalize those key concepts, your life suddenly become very simple. Okay, everybody see how I solve questions, right? It's the same pattern. There's nothing fancy about how I solve it. Okay, but it's effective. It is effective because I've done this so many times. I know if I think along this logic line, I can find my answer quickly and correctly. Right? And that's the things I want to demonstrate to you so you can see that and try to do the same. All right. So like I say in the first lecture, okay, you guys can go back and check out my first lecture. Okay. I say to everybody that I think chemistry is not the most important subject in your life for majority of students here. Okay. I mean it. Okay. I don't think any subject is that critical for your life. But the things I say today, right? Finding all these simple rules, okay, and then the efficiency targeted. Those principles, I think is actually very important. Okay, and can be applied to what we want to pursue in the future. Okay, so I want to share this information with you. Okay, and to be honest with yourself, know what you want to get for this course. Okay, if you cannot come up with a reasonable plan, then come to me. We can talk. All right, and specifically for this course, if you want to really get good scores, the things you should really focus on is my video and hangouts. Okay, I know there's actually tutorial things in the campus. Okay, I think about this. I'm the guy who have been working on this subject for years, right? Almost a decade now. I've seen the questions, I don't know how many times now, right? And for those tutoring sessions, who are the tutors? They are students. Some have to take the JCAM or what, right? So I think it's actually not too difficult to figure out who will be actually has more experience, right? Who have actually think the question really, really hard to come up with a solution that's simplest. Yeah, so make the right choice. Okay, so use the Hangout. Okay, let's start it. Okay, let's start it now. Okay, let's not like that. Okay, go watch the in-person lecture, see how I solve this problem, and follow the same logic. That's the easiest way you can actually get the things that you want. Okay, so do that, please. Okay, so I'm going to actually allow that talking, then we can just finally get to the things we want to talk today. The things we want to do today is actually very simple, very critical though, for chapter 12. because many students actually forget all those simple things. Okay. Well, it's about two topics today. One is actually reintroduce the ICE table. Okay, so ICE table is actually things that you have learned when you're in the high school. Okay, so the key point today is actually how do you know the information provided inside the question? Does a number belong to I, belongs to C, or belongs to E? Okay, so those are the key things you need to become a master. Okay, so we'll do the practice. And I will ask you again and again today. What you do is actually just just answer my question. Okay, based on your feelings. Okay, let's practice that together. So you know you can do this correctly in class. You go back home to your quiz, you know you can do it right over there too. Okay, and these things will become very simple. Okay, so ICE. I stands for what? Okay, initial. C, change. E, equilibrium. Okay, so this is actually the things that you need to have in mind. When you go to your Chincan lab, when you put your reaction together, when you start to keep your reactants, then you start to form the product, right? And then you cook for, let's say, 30 minutes, then you stop it. Okay, and then you have some product, you have some reaction remaining. Okay, everybody is familiar with the things I just said? Okay, I want to actually use that as an example to tell you what is I, what is C, what is E. Okay. So in the beginning, what do I say? I say you put your reaction together, right? And then you turn on your heat. You let the reaction to happen. Okay. So which stage I'm describing? I, C, or E? C. Okay. Listen carefully again. I put things together and I let the reaction to occur. To occur means it haven't occurred. Okay, wording matters. Okay, so every time you see the keywords that start to react or mix together, let the reaction to occur. Those are the things. What if I say, if I give you a concentration or an amount of my reactants, those numbers should go into which row? The I row. Does that make sense? Okay, so I need to do that. Okay. Then I say, after they react for a certain time, okay, my reactants decrease by X amount. Or I say my product increased by a certain amount. Okay. Which stage I'm describing? Change, right? When I say this increase or decrease, that imply changes. Okay, so those are keywords you actually know. Okay. And then I say, okay, after reaction is completed, okay, all the reactions equilibrate. Which stage are we? Equilibrium. Okay, so you need to be crisply clear, know which stage you are, so that you can actually put the numbers in the correct row. Okay. The other very important thing is that when you write these equations, right, which will practice this. I want to draw this to you. Graph all those numbers. Okay. You should know that when your initial conditions plus the change you encountered, and it will eventually give you whatever numbers you're going to see at equilibrium. Okay, so I hope that makes sense to you. You start with this, you have some changes. So at the end, which is at equilibrium, okay, the number will be actually the sum of the first two rows. Okay, so those are things that you will need to become a master. Okay, so any question for the things I just said, because we're going to start our practice now. Any questions? Yes. So the number you see from the beginning and the number you see in the change, if you add them all up, they will be your final, which is equilibrium. For example, I have $10. I give my daughter $3. I think I was $7 at the end. Initial is 10, change is 3, right? Actually -3 because I get out, right? So -3. So at equilibrium, I still have $7. So 10 plus -3 give you 7. That's one. Is that clear? Okay. All right, so if no questions, let's do practice. Okay, so let's read these questions again. At 700K, the reaction below have a Kp value of 54. An equilibrium mixture at this temperature was found to be 0.5 atm each for H2 and I2. Calculate the pressure of HI. Okay, so after you read through this, what's the keyword? Yes, equilibrium is actually a keyword. Okay, the other keyword is actually Kp. Every time I see Kp is chapter 12 question. Okay, and in chapter 12, that's how many equations you can memorize, right? So what the equation is actually memorized for chapter 12. The most important one is actually, do you know how to write the chemical quotient or equilibrium constant? Right. So let me go back to that. Okay, so for a given chemical equation, right, you need to know how to write your chemical quotient, which is actually product over reactant, right? And you can write out a chemical quotient for a reaction under I, under C, under E. Doesn't really matter. Okay. But your equilibrium constant is very different. Even though the formula by itself looks exactly the same of your chemical quotient. But this ABCD, this capital ABCD is not a random ABCD. It is ABCD at equilibrium. It has to be a number on your third row. Okay, on the equilibrium row. Okay, so to make it really correct, and these are the equation. You need to know the difference between Q and K, of course. Okay, Q is actually, you can write out the ratio at any given time. K is a special case, which you can only use the concentration at equilibrium to write it out and it will be a constant. All right? So this is actually the first set of equation that you need to memorize. The second set is really just this, right? If you do some changes for the given equation, and you calculate a new equilibrium constant, right? So the basic idea is actually whatever you do, all those effects will be reflected at the exponent of k, right? If you flip your equation, the new k will be the reciprocal of the original k. If you modify a constant for that, that constant will show up at the exponent of your new k. And that's all. That's all the things you can actually memorize for chapter 12. Okay. Everybody fine with this? Okay, so if you really actually understand the things I just say, then that's all the equation you need to memorize for chapter 12. Now, the things that's important for chapter 12 is actually, can you recognize the numbers belong to which row? Okay, so that's the things we're going to practice now. Okay, so when we read this question, I say the keywords, two things. First, it's actually your KP. Every time you see the question give you this KP, meaning it's a chapter 12 questions, right? Therefore, the equations we just mentioned, you will use those things. Okay, and here it specifically says, at equilibrium, mixture at this temperature was found to be, you have this and that. Okay, so before I actually dive in, you want to ask yourself, the number I see right here, do that belong to I, C, or E? Which one? I, C, or E? Think about this. Okay, this is critically important because once you know that, then things become very easy. I, C, or E? E, how do you know? Yes, because it says at equilibrium already, right? So once you know that, then we can actually go back to our logic flow, the QD path. Q. Okay. You want to know the pressure of HI at equilibrium, right? That's the things you want to calculate. Okay. Then you know the data that you have is that your Kp equals 254. The pressure of your H2 at equilibrium equals 2.5. The pressure of your I2 at equilibrium is also equals to 2.5. Okay. Now, once you understand this, right, then we have plan. Okay, so I'm going to write all these things. H2 plus I2, they give you 2HI. And then you have the I table, right? So now you know that this number, you put it actually right here. That number is going to be right here. Okay? These things, we don't know yet. Okay? But we do know your Kp, which will express as the pressure of your H2, Hi to the second power, pressure of your H2 first power, pressure of your I2 first power. And this thing is going to equals to 54. Okay? So apparently you are going to use your KEQ or KP to solve the pressure of your HI. Okay? So all the things I write here, this guy, these two, those are the pressure at equilibrium, right? Because the things you write here is actually your K, not your Q. There's actually, you can only put the numbers in the third rows into this equation. Okay. So with that being said, apparently this is actually the things that we want to solve, right? PHI is actually the things we want to solve. What's the pressure for your H2? At equilibrium, we know it's actually 0.5, right? So that's how you do this. Same thing for your I2. And these things give you a value of 54. Therefore, you can actually know your PHI will be the square root of 0.5 times 0.5 times 54. And that will give you a value of 3.68. Okay. So this is actually the question you have to see over and over again in chapter 12. Okay. Any questions for this? Okay, let's recap the things quickly. When you read the question, you see the keyword KP, therefore you know it's actually equilibrium problem, right? And you see the keyword at equilibrium, and it tells you the concentration of your H2 and I2 for specific numbers. So you know those specific numbers belong to equilibrium condition. Okay. Then you use your KP and plug in the numbers that you know to solve the only unknowns in this question, and you can get your answer. Okay, so let's take the logical. Okay. So if there's no more question, let's your questions? No. Okay. So let's do it again. Okay. Question number 5. At a given temperature, 2 atm of H2 and 1 atm of I2 are mixed and allowed to come to equilibrium. The equilibrium pressure of HI is found to be 1 atm. Calculate the Kp for the reaction at this temperature. Okay, what's the keyword here? And there's actually multiple, right? So let's do it step by step. Kp first. So that you know, chapter 12, right? And then mix and allow to come to equilibrium. Okay, this is actually a sentence that tells you, I'm going to give you some number in I, right? I'm going to tell you some information at equilibrium. Okay, so the ice table becomes critically important right here. Okay, because you want to make sure you know you put the right number at the right row first. Okay, so those are the things that we know. So we can actually reorganize our thought and tell us, okay, what's the Q? What's the things we are trying to solve? Okay, you want to calculate your Kp, right? Meaning you need to actually know all the pressures of all species at equilibrium so they can calculate your Kp, right? What's the data that you have? Okay, so here you can see that actually multiple numbers, right? So the way you handle this data in chapter 12, you start with write out the equation, write out your ICE. Okay, so I'm going to do that. Equation is H2 plus I2. That give you 2HI. Okay, and I write ICE like that. Okay, so once you finish that, then you start to read the question more carefully. Okay, it says 2 atm of H2, 1 atm of I2 are mixed. Right? So that you know, for your H2, I have a number of 2, right? Which row should you put in? Initial, right? So you should put 2 right here, right? 1 ATN of I2. You put 1 here, right? Everybody fine with the things I just did? Can you do it yourself? Okay, let's just make it most, right? Make sure you can do the same thing I'm doing right now. Okay, so it says, once you mix land, you allow land to come to equilibrium. The equilibrium pressure of HI is found to be 1 ATM. So apparently you actually put the number in the HI column, right? Or where? I, C, or E. Good. Okay, so let us actually set up that you have. Okay, so I draw a line between the between C and E because data I want to add my I and C, so I can actually get the E. Okay. So now it's actually a critical step that you to become a master. Okay. So you say the question tells you, okay, I start with this, and I allow it to come to equilibrium, right? You should notice that we have nothing in the row of C, right? So this actual part, you can actually fill in the information. So what you do, or what we're going to do is actually, let's say there are certain change occurred through this time course. Okay, then I know there will be X more of H2 is going to change, even though I don't know the exact amount. Okay, so I write minus X over there. Okay, and then you should see that this equation tells you if I consume 1 mole of H2, I'm going to consume 1 mole of I2 at the same time, right? So when you write out the minus X for your H2, you know you are going to consume that much of I2 as well. Okay? What happened to your product? What should you put on the product side? Plus 2x, right? Y2. Yes. The coefficient matters. Okay, so if this is actually where you started, that's your reference, right? Then when you write out other terms into actually reference back to where you started. Okay, so here you write minus 1x because you know the reactant is going to be consumed, right? The reason you write out 1x is because the coefficient ratio reference to your H2 is 1. Therefore, you say minus 1x. Then the product will form after you consume your reactant. Because you consume 1x, 1 H2 is going to give you 2 HI. Therefore, the product you're going to enter here will be plus 2x. Okay? Does that make sense to you now? Everybody can do this? Okay. After you finish this one, then what you do is actually you add up your I and C, and they will give you the E. Okay, so you know at equilibrium, this will be 2 minus x for your H2, 1 minus x for your I2. What's this number? What's that number? 0, okay, because it doesn't provide any information of HI at the initial, right? So under the case, the default will be 0. Okay. So after you write out these things, then you will realize that
when you add up these two, it's going to give you the value of 1, right? Therefore, you know your 2x is going to equal to 1. Therefore, you know your x is going to equal to 0.5, right? So once you see that your x is actually 0.5, then you see these things too, right? Therefore, you know the pressure of your H2 at equilibrium is going to equal to 2 minus 0.5, which will give you a value of 1.5. The pressure of your I2 at equilibrium will equal to 1 minus 0.5, which is going to equal to 0.5, right? And then the pressure of your HI at equilibrium, it's already given, is equals to 1, right? So once you have this information, then the things you want to do is actually calculate your Kp, right? Which is actually the pressure of your product, Hi to the second power, over the pressure of your H2 first power, pressure of your I2 first power. Then what you do is actually just plug in the number, this to this, that to that, and that to that. You'll be okay. So once you do these calculations, then you'll be able to get a number of 1.333. And that's actually how you solve this tough question. Okay, everybody follow the logic here? I hope it's actually clear. Okay, any question for this? Yes. So this is actually a part that you need to have in mind, because in these questions, do you see they provide any specific information for changes? It doesn't, right? It doesn't say A increased by certain or B decreased by certain. That's not there, right? So, but these things will exist because you can see going from initial to the end, changes is always there. Therefore, if it doesn't tell you, you will need to actually write out that X yourself, which is actually the most difficult part for many students. Okay, so you actually get used to it. Okay, so we start from the H2, we say it decreased by X amount, X more actually, right? And then based on the coefficient, you can write out either it's going to be decreased by X or decreased by 2X, depending on the coefficient. Okay, so in this case, because coefficient ratio between your I2 and H2 is 1 to 1, right? That means actually we're going to decrease by the same amount. Thereby, write minus X for my I2. The product, on the other hand, you see, if you consume 1 mole of H2, you're going to produce 2 mole of HI. Therefore, I know it's going to increase, right? That's why I put a positive sign. I put 2X because the coefficient ratio is 2 to 1. Therefore, I wrote 2X over there. Is that clear? Okay, very important thing. Okay, make sure you know how to do these things by yourself. All right, one more. Okay, in the reaction below, 0.5 ATN each of H2 and Br2 were placed into 1 liter of flask and allowed to react. Given the Kc is equals to 4, calculate the equilibrium pressure of HBr. Okay, what are the keywords here? Okay, every time you see the K, okay, that tells you it's chapter 12 questions, right? Then you read this. You have information about your H2 and Br2. And then it says allow to react. Right? So let me say actually whatever number was provided over there, they will go to the initial. That is allowed to react, meaning that haven't react yet. Okay. Okay, so once you have some idea, then you can actually write out your QT pad, right? Q. The things you want to calculate is actually the HBr pressure at equilibrium, right? Data. Okay, write out the equation. H2 plus Br2. They give you 2 HBr. Okay. And then you have I, C, and E. Okay, so here it says you have 0.5 atm each of H2 and I2, right? So we know it has to be in the initial row. Okay. And then I also know the Kc, which will be your concentration of HBr seconds power, concentration of your H2, concentration of your Br2 to the first power. Okay. So one thing you should actually notice that is the unit here, right? The unit is what? ATN, right? But it gives you what? Kc, right? So what is gas? What is actually concentration terms? These two are not the same. Okay, so if you want to use the unit of ATN, what you really need is actually your Kp, right? Which will be the pressure of your HBr, seconds power, pressure of your H2, pressure of your Br2, right? So I guess there's actually one more equation I forgot to mention. Is that this two is actually convertible, right? So we know, okay, just make sure that you know where the equation is. I want to go back to the hangout. It's right here. Okay, the equilibrium constant P equals to equilibrium constant C times RT to the delta n's power. Okay, the delta n was calculated by the differences of mole between your product and reactant. Okay, I'm going to show that quickly to you now. So we say this H2 plus Br2 give you 2 HBr. And all of them exists in the gas form. Okay, so the Kp is going to equal to Kc times RT to the delta n's power. Okay, of course, this is actually things you need to put R, and then depending on the temperature you have in Kelvin, you can plug all things in. Okay, but the key is actually how do you calculate the delta n? The delta n is actually the number of moles in the gas form on your product side minus number of mole of gas molecule on your reactant side. Okay, so if you look at this equation, for example, on the product side, how many gas molecules you have? 2, right? On the reactant side, how many gas molecules do you have? It's also 2, right? 1 plus 1. Okay. Therefore, your delta n under this case will be 2 minus 1 minus 1, which is 0. Okay. So that means this will be Kc times half t to the 0th power. And we should know that by now, no matter what your basis is, as long as your exponent is 0, these terms become 1, right? Therefore, you know your Kp is actually the same as your Kc. Okay? So, get back to here. Then we know the Kp is actually equals to your Kc equals to 4. Right? All right, so once we have all this information, then we can just start our plan. So if you re-examine your eye, right now you should be able to confidently say there's 0 for here. Right, because they don't provide information of your HBI initially. Therefore, we put 0 over there. Change. The question doesn't mention anything about change, right? Therefore, it becomes our job to put the x in. Therefore, we know reactant is going to minus x, right? And then you start to compare the coefficient. This is actually 1 to 1. Therefore, you know into minus x. And this is actually 2 to 1. Therefore, you need to write out 2x because it's product. Therefore, you write 2x plus 2x. Okay? Then you know at equilibrium, you can write 0.5 minus x, 0.5 minus x, and 2x. Okay, so those are the things that you should actually use and plug in your Kp. Right? Therefore, I know my Kp, which equals to the pressure of my HBr seconds power over pressure of H2, pressure of Br2, which is going to equals to 2x squared, 0.5 minus x, 0.5 minus x. And this whole term is going to equals to 4, right? So now the question is actually, can you solve this equation, right? So you can actually expand the things. Okay, so you can actually, so this is actually how I write it. Right, this whole thing can be simplified as this. Then I take the square root on both sides. Therefore, I got this, right, square root SQRT. And then you're going to get 2x is going to equals to 0.5 times 2 minus 2x. Move a negative 2x to the left. Then you get 4x is going to equals to 1. Therefore, your x equals to 0.25. So you can just solve your x by solving this equation. Okay, so once you solve x, you go back and check what's the things you want to solve. It's actually the pressure of your HBr equilibrium. The pressure of HBr equilibrium is equal to 2x, right? Therefore, we can say the pressure of HBr equilibrium is going to equal to 2 times x, which is 2 times 0.25, which is going to give you a value of 0.5 atm. Okay, so this is actually how you solve these questions. Okay, so again, the key is really, you know how to actually write your ice table. You know where to put your numbers. You know how to write your changes. Okay, so those are the key. If you are actually good at those things, solving this problem should be actually straightforward enough. Okay. Any questions for this? You're good? Okay, then we can actually talk about the very last topic. the Le Chatelet principle. Okay. So what is Le Chatelet principle? It is the principle the scientists use to predict how the reaction is going to move when you produce perturbations. Okay. The key idea is that your system is at equilibrium. Okay. Then you provide the perturbation and you see how those things will change. Okay. And basic idea is that we know things happen in a way where the destination will be your equilibrium. Okay. So scientifically, when people describe these things, they're using a funnel as an example. Okay. So let's say you're starting from here, then if you put the things, if you put a marble inside this big funnel things, it's going to circling and going down to the end, right? The end is actually your equilibrium. Okay. So no matter what you do, this perturbation, right? In the end, you want to come back to your equilibrium. That's actually the constant number one. Okay. So what the Chatelet principle really saying is this. Okay, let me give you a chemical equation. 1A plus 2B, they give you 3C. Therefore, you know your K is going to equal to C to the cube, A to the first power, B to the second power. Okay, I guess everybody can see these things now. Okay. So let's say if today I decrease the concentration of A, okay, I decrease my concentration of A, okay, and then you ask you, the reaction will move to the product side or move to the reactant side. Okay, those are the questions you're going to encounter. Okay, so how do you actually understand these things? I would suggest you look at this equilibrium constant equation. Okay, equilibrium constant is a constant. That means the ratio between your product and reactant need to be satisfied eventually. Okay. Let's say if I decrease my A, okay, therefore you know you actually deviate from your equilibrium now, right? So the system will do what? If you remove A, then I will need to produce more A to compensate that, right? So that I can keep my equilibrium constant the same. Everybody know why does that? Okay. So if you remove A, then to keep the constant the same, the reaction will move to a direction that produce more A. Okay? Since you want to produce more A, therefore you know the reaction will shift to the left. Okay? On the other hand, if I say, if today I add more A, okay, I add more A, right? That means actually your reactant ratio, the reactant within this ratio, okay, you can simplify this as actually product over reactant, right? If I add more reactants to keep my K the same, that means the reaction is going to produce more product so that the K will remain a constant. Okay. Everybody still follow? Okay, good. So that's actually a basic concept. This is actually the king, right? You want to keep that thing constant. Okay. When you see the change, it's going to change some of the things. Then the reaction will move to a direction that compensates the change. Okay. And the things that can actually really change your equilibrium constant. That's actually only three things. When I say only three things means anything outside the three, if they show in your quiz or midterms, That is not your answer. Only the three things: concentration, pressure, and temperature. Okay, concentration and pressure are equivalent. Okay, so always use this to make your judgment. Okay, this is actually a constant. Okay, so your product over reactant ratio is the key. Okay. Temperature is actually an interesting thing. Okay, so temperature will be related to the terms that we have learned in the past. You may actually see a question say, the chemical reaction is exothermic, or the chemical reaction is endothermic, right? Those are the terms that the temperature will have effects. Okay, so what does endothermic means? What's endothermic? Meaning your system need to what? Absorb heat, right? Your system need to absorb heat to make the reaction to occur. That means, okay, let's use this example, okay? Then you know you can actually rewrite the things. Let's call it endothermic. Does that make sense to you? Your reactant absorb heat to produce product. That's what I mean by endothermic. Okay? On the other hand, exothermic will be your reactant and product, your reactant reacts, produce product and a lot of heat. Okay, so you need to be crystal clear knowing the difference between endothermic and exothermic. Endo means actually absorbing heat. It's the reactant absorbing heat to produce the product. Exothermic is actually your reactant reacts to produce a product and release a lot of heat. So it's actually a product plus heat. Okay, so this is actually very important because if I say if I decrease my temperature, okay, if I decrease my temperature for an endothermic reaction, okay, what happened to your reaction direction? It's going to move to the reactant or move to the product? This is not the same thing. Let's say I increase the temperature. Maybe that's easier to comprehend first. Okay, if you increase the temperature, what happened to your endothermic? Yes, it's going to shift to the product side. Okay. So when I say increase temperature, is actually I'm going to provide a lot of heat, right? So once you increase your temperature, your reaction will shift to the product side. Okay. Of course, if you want to actually follow the same logic, right? You can consider heat is actually part of your reactant. Does that make sense? Because you still want to keep your K the same, right? You add in more heat, you add more reactant, therefore it's going to shift to the product side. So that the product over reactant ratio will still remain the same. Okay? So on the other hand, if you have exothermic reaction, if you increase the temperature, then you have a lot of things on your product side, right? Therefore, the reaction will move to the left to compensate for it. Okay, so this will shift to this, they will shift to left if your temperature increases. Okay, everybody follow? Okay, So we can actually finish the very last questions before we close out this lecture. Okay, the very last question we want to go through is practice this concept. Okay, consider reaction N2 plus 3H2 that give you 2NH3, which is exothermic. What would be the effect on the equilibrium position of removing N2? Okay. So question is actually predict reaction direction, right? Data that you know, the equation you're writing is actually N2 plus 3H2 equilibrate with 2NH3. And this thing is exothermic. That means you want to write the heat on the product side. Okay. Okay. So this is actually the things that you have, right? So you can actually write the things, right? For your K, it will be NH3 heat. Reactant will be N2 3H2, right? Of course, this is just a ratio. Okay. It's not really K, okay, but I guess you can just think this way. Now it asks you if I remove what? N2, right? So you want to actually make these things less. Right? To keep your K the same, then you know that you need to move to the reactant side. Okay. Okay, so it says N2 is going to decrease, right? To compensate that, therefore, you know the reaction is going to move to the reactant side. Okay? Everybody fine with that? Okay, so once you can do this, the next thing is actually I'm going to ask you a few questions before we end this today's sessions, okay? Start with the simple one. If I add in more H2, then just tell me reactant or product side is going to move to. Good. Okay, so product side. Okay. If I ask you, if I increase the temperature, then it's going to move to reactant or product side. So increased temperature means actually put in a lot of heat, right? That means right now your product amount increase, right? But you want to keep the same ratio. Therefore, you need to increase your reactant amount. Okay, so this will move to the reactant side. Okay. It's very important that you know the concept. And once you know, then this becomes easy. Otherwise, it's quite confusing to many students. Okay. Next. This is actually an interesting twist. So if I say I'm going to increase, I'm going to compress my container. Okay. Which direction would this equation, would this reaction go to? Okay, so how do you think about this? So when you compress your container, what does it mean? You increase the pressure. right? So if you increase the pressure, then the system want to actually compensate the change, right? So how do you actually know the pressure of your reaction product? You count the number of gas molecules in the equation. Okay, now tells me how many gas molecules you have on the reactant side. Everybody follow this? Okay, 4. How many on the product side? 2. Okay, so if you have an equal amount of reactant and product, okay, the reactant is going to give you a higher pressure because you have more gas molecule in your given space. Okay, it's very simple. Okay, so right now you compress that. Okay, the pressure is going to get very, very high. Okay, then the system will actually move to a direction that lower down the pressure. Right. So going to lower down the pressure, you know, go to the product side is the way you can lower down the pressure. Okay. Therefore, you know, if you compress your container, then it's going to move to the product side. Okay. Everybody how it says? Okay. On the other hand, if today I say I expand my container, it will be the opposite. Okay, because once you expand your container, the pressure drop. Then your system will actually retain that pressure. It's going to move to the reactant side. Okay, so you have to be very clear about the wording, what it really means, right? I said there's only 3 factors that's going to affect the equilibrium: concentration, temperature, and pressure. Okay, so you need to actually know the wording associated with that. Okay, very last one. This is actually all the possible things you're going to see for this type of questions. You will definitely see this. Yes. If you see these things, right? If I throw in a catalyst for this reaction, I will actually change the reaction direction. The answer is it doesn't. Okay, only 3 things going to change your reaction direction, which will be concentration, temperature, and the pressure. Cool. That's it for today. Thank you.